everybody, today we are doing another video. And today we are explaining the difference between exponential an exponential line of best fit and a linear line of best fit. Now there are other lines of best fit such as rational lines of best fit and quadratic lines of best fit. And as you can tell, these lines of best fits are used for quadratic type data, linear and rational type data. This is for exponential type data. So, because as you can see, it's going up every time I'm at a longer rate. So, of course, you can definitely see that this would averagely be something like this. And this would probably be, this would definitely be a line of best fit, an average line of best fit, for the reason that it increases about approximately a different amount every time, because just look at this. It looks exponential. And if you did a linear line of it, it'll probably go like this, giving it a pattern of going here, down, and here, and back up. So we couldn't use, because patterns are make it a bad line of best fit. You probably either need to change the type of line of best fit that you use. Randomness actually makes it better. So the more random the data is, the better it is. The better the actual data is. Now this one would be better for linear, because it's a really bad straight line, but it's a straight line nonetheless. So here we have just like a straight line, and if we did an exponential like this, it would have it right here, and then a little bit right here. The bottom would be going like this, and there would be just like a giant cluster right here. So it wouldn't be a very great line of best fit. And it's really hard to do this, make a line of or if you want to figure out if it's a better line of best fit, you use a residual graph, which you probably have heard of in my other videos. Residual graphs are basically just lines, or I may have not talked about it, but residual graphs are basically just lines, and when you make this, basically just twist it so that it's a straight line instead of a curved one. And then all the points from that, basically that's the residual graph. And you plot it by having the x value instead of the y value. You have the residual in order to plot it. That's mainly what you do for linear, but it may be different for exponential. You normally we use a scientific calculator from exponential because it's difficult to tell how to do the exponential. So we just use I would normally use a scientific calculator. And we will come back for practice very soon. Okay, so we're back, and now I've gotten a few problems that we can do, and not really problems, but a few pictures that we can use for explaining what or telling the difference between exponential and linear graphs. Well, exponential and linear scatter plots, and exponential linear of line of fit. So if you can, put a finger over your put a finger and make a line of best sketch a line of best fit with your finger, or if you can. If not, try and sketch the points and then draw a line of best fit. I'll give you a little bit of time to do it, but if you need more time, you can pause the video. Okay, so now I will give you a visual of what it would look like. Whoops. So it will just kind of like go like this. But which one is this? Is this a linear or an oh? Is this a linear or an exponential line of best fit? Would it be an linear or exponential line of best fit? So you should be able to get through a bit quickly, but you probably are stumped by this. You may be stumped by this. This is actually an exponential line of best fit, but it's been translated. Well, it's not been translated. It's been transformed. It's been reflected over a certain axis. So, but it would probably be something like this. So it doesn't have to be perfect, but it should be something close to that because it's sketching. You're not going to get a perfect answer. So now let's go on to the next one. Now this should be pretty straightforward. Which one is this, linear or exponential? I'll give you a little bit of time. So, this is actually linear, you should know. You should know this by now, but this is linear. So it would be approximately something like this. This is difficult. Yeah, I think this would be an approximate amount. Yeah, that would be an approximate amount for what this is, and so it'll just go like this. So let's go on to the next one. So this is another one. You don't need to look at the city MPG and the HYW MPG. I have no idea what those mean, but I had this just for the scatter plot. So I'll give you a bit of time to figure this out on your own. But as you are doing this, make sure that you know which one, if it's linear or exponential, in sketch a graph. Okay, so we are back, and this is a linear, well, not a linear, an exponential graph, and it would sketch something like this. These outliers really skew it so that it would get farther out. If not, it would be more like this. But that is, we will go into one more, or that may be the last one. Oh no, we have this one left. So now check if this is linear and exponential, and I will give you a bit of, and sketch a graph with your finger or sketch it. If you need to pause, you can pause if you need more time, but I will give you a bit of time in the video. Okay, so it's kind of difficult, but if you look closely enough and check it, it's actually it's more linear than exponential. So you can see that this is if you sketch this, it would be something like this. There. You can slow it down if you needed to, but I think that everyone just got the gist of what it is. So that is basically all that there is. That is basically all that there is, and I just hope you had a great day. You hit the subscribe, you hit the bell, smash that like button, and make sure to leave a comment on what I can do better, and just leave a comment on what I can do well so I don't make sure not to change it. Bye.